Hello and welcome to another home learning video made by Swessit. Today we'll be looking at equivalent fractions. To start things off, we need to understand what is meant by equivalent fractions. Equivalent means a value is equal to another value, whereas a fraction is a smaller part of a value or an object. So an equivalent fraction is a fraction that is equal to or means the same as another fraction but written differently. And as we are looking at fractions, it's worth recapping that the numerator is the top number and the denominator is the bottom. So there are a few ways we can do this, and the first way we're going to look at is by using a fraction chart. These are very handy tools that allow us to clearly see what fractions are equal to another. For example, if we draw a line straight down the middle from 1/2 all the way to the bottom, we can see that the fractions that match up exactly to that line are equivalent to 1/2. We can see that we have 2/4, 3/6, 4/8, 5/10, and 6/12 on this chart. Now there are some denominators that won't work with 1/2. If the number is an odd number, we won't be able to use it to equivalent as 1/2. As you can see, our half line goes straight through a third, or a fifth, or a seventh, and so on. Now most fractions have equivalents, but some will have more than others. So let's move our line and look at another one. Let's move it to 1/3. Again, the fractions that match up exactly to the line are equivalents. Now we can see that we have 2/6s, 3/9, and 4/12, and they're all equivalent to 1/3. We'll move it one more time, this time to 3/4. And now we can see we have 6/8, 1, 2, 3, 4, 5, 6, and 9/12, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they're both equivalent to 3/4 on this chart. Now it's worth remembering that there are obviously more fractions than there are on this chart. Next up, we can use diagrams to help us. Over here we can see a fraction 1/2, and we know there are lots of different ways of writing it, and we've seen some of those already. Over here we have a diagram representing 1/2. It's a rectangle. I've split it into two pieces and I've shaded one in. So that is 1/2. Now let's add another layer. So I've added another 2 squares and shaded another one in. Now I've got 4 squares in total and I've shaded 2. So this shows us that 2 out of 4, 3/4, is the equivalent to 1/2. I can keep adding layers to my diagram of 2 each time, and remember to shade in 1. Now this leads to 1/2 equaling 2/4, 3/6, 4/8, and 5/10. These are all equivalent to 1/2. Now, I would only recommend using this method up to perhaps tenths. Numbers get bigger than that, they can be quite tricky to draw. But let's look at a slightly more challenging one. This time our fraction is 3/8, and I've shown this by drawing another rectangle, split it into 8 equal pieces, because 8 is our denominator, and shaded in 3 of them, as 3 is our numerator. Now each time I add to this, I must add another layer of 8 and shade in 3. So I've got 6/16, got 9/24, and then 12/32, as we can see down here. These are all equivalent to 3/8. Now the last method we are going to look at is by using our knowledge of times tables to help us. By looking at the fact from the last slide, we can see a pattern in both the numerators and denominators. Numerators increase by 1 each time, Now denominators increase in twos. So you see 1, 2, 3, 4, 5, and then 2, 4, 6, 8, and 10. We can continue this forever if we wanted. So we've got 6 twelfths, 7 14ths, and so on. We can make it slightly more complicated by multiplying the numerator and denominator by the same number. It is super important that this number is the same. So down here we have 2/5. To find the equivalent to this, let's multiply. Let's start with 2. So 2 times 2, we know is 4, and 5 times 2 is 10. So we know that 2/5 is the equivalent to 4/10. Let's go a bit further and multiply each one by 6. 2 times 6 we know is 12, and 5 times 6 is 30. So 2/5 is the same as 12/30. And of course we can continue in this vein if we wanted to. So let's link it to some questions. Questions are asking you to make one whole by adding fractions of different denominators. For example, as you can see, 1/4 plus something equals 1. We can choose any of the 3 methods, but we first need to work out what we need to add. We can add 3/4 to 1/4 to get 1 whole, but we need the denominator to be different. So what is the equivalent to 3/4? Well, we could draw a line on our fraction wall, and as long as the line matches up, we would have an equivalent to 3/4. So again, we can see 6/8 or 9/12. We could draw it using a diagram. We have 3/4, 6/8, 9/12, 12/16, 15/20, and so on. Or we could use knowledge of our times tables, adding 3 each time and adding 4 each time at the bottom. They should all show the same equivalent, so we can use that to check our work. Well, that's it for equivalent fractions. Good luck, everyone.